So, a very good afternoon to all of you. We are here with our next webinar on the topic Blacknet-driven collusive attacks on social media. We have with us Dr. Tanmay. Let me introduce him, and after that, he'll be taking up the stage. So, Professor Tanmay is an assistant professor and a Ramanujan Fellow at the Department of CSE, IIIT Delhi, India. Prior to this, he was a postdoctoral researcher at University of Maryland, College Park, USA. He completed his PhD as a Google India PhD Fellow at IIT, Kharagpur
Okay.
in 2015. His research group, LCS2, broadly works in the areas of social network analysis and natural language processing, with the major focus on designing data driven solutions for cyber informatics. He is a recipient of several prestigious awards, including Google and IBM Faculty Awards. He is involved in mentoring several tech startups too. So, hello and welcome, sir.
Hi.
We are blessed to have you. The stage
Thank
is
you.
yours. Thank
Thanks.
you.
Thanks, Sachin, for the generous introduction. And thanks, IEEE Signal Processing Society Delhi chapter for giving me the opportunity to talk about our research. So, in today's talk, the plan is that we're going to talk about one of our ongoing research on online attacks on a particular type of attacks in online social media. In particular, I'm going to talk about collusion on online social media, a group of content polluters who are part of a covert ecosystem to manipulate online reputation. So I have used the term, as you see in the on the slides, I've used the terms sophisticated content polluters, covert cooperative ecosystem, and manipulate online reputation. These terms are slightly, they may look like slightly vague. I'll discuss about these terms later. But in general, we have seen many types of attacks, many types of fraud activities in online social network, web in general, including say attacks in financial sector, right? Fraud activities in Facebook, Twitter, fraud activities in even matrimonial sites with fraud accounts, etc. So here we'll look at another types of attacks, right? Another type of attack altogether, which deals with groups, groups of users in a very secret environment, which looks like a normal activity, not a fraud activity. And we'll see how we can detect them using different computational techniques, and how we can analyze those groups. So before going into the technical part of the presentation, let me quickly introduce my group. I lead a group called LCS2, Laboratory for Computational Social Systems, as Sachin mentioned, at IIIT. We are a group of researchers, PhDs, postdocs, RAs, undergrad, master students, working broadly in three areas. Two broad areas are NLP and graph mining. Okay, in NLP, we are currently interested in two domains. One is called text summarization, another is called conversational modeling, designing different chatbots for different use cases. In pure graph mining, we are interested in different structural properties of a graph, okay, or a network. In particular, we are interested in something called communities or clusters in graphs. But our major focus is to understand different social computing aspects, which takes some part of NLP, some part of graphs, and deals with problems like misinformation, different malicious activities on online social network. So one such problem is collusion, which I'm going to discuss today. The other two problems which we are uh, actively working on include hate speech detection in Indian context, Indian languages on social media, and fake news again in Indian context, or certain types of topics like COVID. And all these problems, the projects are funded by industries including Google, Wipro, Accenture, and so on. So today's topic is collusion. So we will learn how we can detect, how do we define collusion in online social network, how do we detect them, and how do we understand their properties, behavioral properties. So what is collusion? So as Oxford Dictionary defines, collusion is a secret conspiracy or cooperation to deceive others. Okay, so collusion happens everywhere in our society. Right in, we all know that in 2016 US election, there was a collusion between Donald Trump's camp and Putin's camp, right? I am pretty sure something has happened this time as well. We are looking at it. This kind of collusion happens in other social media platforms, including, discussion forums like Reddit or Quora, where colluders are involved, are become part of different discussions to manipulate user sentiment, right? For example, we have seen in Indian election context, in the context of Indian election, or even Bihar election or Delhi election, CM election, that different such colluders took part of different discussions and manipulated users' opinion. Okay, collusion also happens in e-commerce services like Reddit, Amazon, Yelp, Flipkart, etc., where these colluders are hired to promote or demote certain products. Okay, and unfortunately, collusion also happens in scientific world. Okay, where editors in different journals often collude to increase the impact factor of their respective journals, right? You may have heard that Thomson Reuters, which is currently known as Clarivate Analytics, they blacklisted. This Thomson Reuters is responsible for impact factor calculation of different journals. Okay, they blacklisted more than 100 such journals, highly reputed, highly impactful journals, due to these collusive activities. Okay, there was a clear evidence that one journal tried to increase the impact factor of other journals, and therefore they banned those journals. But here in this presentation, we'll mostly look at collusion in online social network, in particular on Twitter and Twitter and Facebook and other e-commerce services. So if you want to know more about the nuts and bolts of collusion, you possibly would like to read this book, this famous book called The Economics of Collusion, by Robert Marshall. Okay. So this is the plan for today's talk. I'm going to talk about collusion, our research on collusion online social media, and the second part, I'll very briefly talk about the other research that are going on in our lab. Okay. So I'm pretty sure. I mean, this slide is designed for for offline presentation, assuming that audience is sitting in front of me. So, but still, if I ask that how many of you do not have a social media account, I'm pretty sure nobody is going to raise hands, right? I'm pretty sure that everybody has existence in at least in any form of social media, say Facebook, Twitter, LinkedIn, right? Instagram, etc. And I'm also sure that all of you guys want to increase the popularity of your post as well as your user accounts, right? In terms of, say, more number of followers, more number of retweets of your tweets, more number of shares of your post, and so on and so forth, right? So but I'm sure that you believe that publicity is really hard. I mean, it's very difficult that organically your account is getting tremendous amount of followers over time, unless you are a celebrity. Okay, you are a film star or you are other kind of celebrities. Otherwise, it's very difficult to grow the popularity of your account or the popularity of your post, right, within it's a limited time period. But it happens that in certain times you need to spread your message to large set of audiences, right, within very small amount of time. Then how do you do that? So I faced the same problem when I joined IIIT. I was given the responsibility of publicizing a workshop. Okay, and that time I was not that social media savvy. So I was not on Twitter. So I was given the responsibility to promote the workshop, and I wrote a simple post about the workshop, assuming that since this is a technical forum, I'm pretty sure that everybody will register, or my post will get a lot of shares or likes. But I was completely wrong. So within 3 days, I only got 5 retweets of my post. Okay, and the fun factor was that at that time there were around 37 members in our lab who were very active on Twitter. Even they did not care about sharing my post, right? So that was surprising. But then we had a research paper. We were working on similar topics, and we knew that we knew the shortcuts. We knew that how within limited time we can boost our post, right? And we adopted that shortcuts. And you see what happened after 40 minutes after adopting the shortcut, and look at these statistics. So within 40 minutes, we saw an increase of number of retweets to 70, right, and number of likes to 10, right? So now what is this shortcut? So I'm trying to discuss this thing in this presentation. So the shortcut is, but just hold on for a minute. So I'm pretty sure that you have heard about such quick increase of popularity of different social media accounts, right? All around these news articles, newspapers, etc. For example, in 2012, Louise Minch, she is a blogger in UK, and she is a member of conservative. She's a Conservative Party member. Her account got increase of number of followers from 40,000 to 1 lakhs within 1 hour, right? So a sudden boost in number of followers automatically raised alarms, and people started thinking that what happened. Similar such things happened in Italy, where several Italian professors casted doubts about the popularity of political leaders. They said that most of the followers of these political leaders are basically bots or paid accounts, right? So now, if you are wondering that who are the responsible person behind this behind this black magic, so I would suggest I would then suggest that these are the underlying users or underlying companies which are responsible for this kind of sudden boost, right? So they are black market services. So there are many such black market services available online which are responsible for giving you a lot of followers, retweets, shares, etc. And if you look at their activities, okay, in broadly they are divided into two groups. Okay, so one type of black market services is called free premium service, which is very straightforward. You go and give them money, you pay them lump sum, and they will give you followers, retweets, shares, etc., etc. But they charge lump sum. Okay, this is really lump sum. The reason that we tried, and the amount was around around $10 for 100 retweets, if I'm not wrong, and that's pretty high, right? If you do not have enough money, you can still opt for these services, right? There is something called freemium black market service. In freemium black market service, you go and you become a part of the black market service. You do not need to pay anything. You become a part of the black market service, and then you act on behalf of them. Okay, for example, you start retweeting their customers tweet, you start following their customers account, and then you gain your virtual credit. Use this then you use the virtual credits to fulfill your expectations. So if you want to increase the follower count of your account, you use the virtual credit, and accordingly you gain followers. So in freemium black market service, if you understand the dynamics properly, the customers themselves become the part of the black market services at a certain point in time, right? So this freemium black market service customers exhibit a mix of both inorganic and organic activities. Now, what do I mean by organic activities? Organic activities are those activities which happen in general. I mean, which happen organically. For example, say I am a cricket lover. I organically follow Sachin Tendulkar's Twitter account, right? But what are inorganic activities? The inorganic activities are basically, you know, those activities which happen underneath the table, right, without any preference as such. So all these black market activities are inorganic activities. So in case of freemium services, customers at certain point in time become a part of the black market services and exhibit all these inorganic activities, whereas when they are normal users, right, and they do all these organic activities. So you see a mixed behavior of both inorganic and organic activities in case of freemium black market services. So therefore, it's very difficult to detect their activities in a real time. So examples of such black market services include like for like, they view me, just retweet, view like hits, and so on. So these are popular black market services which provide you this kind of inorganic artificial services, I would say. Okay. So, and what they provide you in case of Twitter, they provide you retweets, they provide you followers, provide you likes, and so on. Okay. So and as you understand, this is completely against the terms and conditions of Twitter, because Twitter clearly says that Twitter strictly prohibits the purchasing and selling of account interactions on our platform, right? So this is basically selling your account, right? Because your accounts are being compromised when you're part of the black market services, right? So now you remember the example that I gave a couple of minutes before about Louise Minch, right? Her account got a lot of followers within certain time. So you may wonder that possibly these kind of activities are very easy to detect, right? Because if over time, if you count the number of followers of a particular user, right, and you see that a sudden spike at a particular time point, you possibly understand that there is something fishy happening at that time, as you see here in this figure, as something fishy happening here, and then you analyze those accounts who are responsible for this spike, and you flag some of them, right? That's very simple and straightforward. Then why do we need to design sophisticated methods to detect these collusive activities? But let me convince you that no, this is not as simple as that. Okay, so collusive activity doesn't grow in this way, right? Doesn't grow in this way. Rather, it grows in this way. Okay, you see that the bottom figure is more natural and more similar to a kind of a following activities of a normal user, right? You see certain time it decreases, then increases, decreases, increases, and that's the normal behavior. So what I mean to say is that collusive users, okay, they are driven by the black market services in such a way that their activities look like very similar to the normal user activity. Okay, so that they are not flagged, they are not banned by Twitter or other social media platform. Okay, so therefore we hypothesize that collusive activities are very different from normal fake activities that we know of in general. Okay, because normal fake activities are very different from normal user activity, whereas collusive activities are not similar as fake activities. It's very similar to a normal activity. Okay, so we started off, and as you understand, this black market driven activity detection, etc. This was I mean, when we started working on this 3-4 years back, this was a quite hot areas, and there were very less papers on that, no publicly available data set on that. So we started designing our framework by collecting first data from different black market services. Okay, so we started curating data for Twitter, YouTube, Amazon, and Flipkart, because these are some of the famous online platforms which are often being compromised, often being manipulated by these black market services. We we designed something called active probing. I will discuss later. Using that active probing strategy, we collected data from black market services. Then we started understanding the behavior of collusive users, right? Then we felt that possibly individual level behavior may not be enough, because these colluders act as a group, okay? And when a group of users act together, then the impact that they have on the social media is huge, okay? So we need possibly different types of methods to detect group level collusive activities rather than individual activities. And then we again design methods for understanding the spread virality of this collusive post, okay? So just for the interest of time, I may not be able to go through all the stages. I'll mostly focus on our models for detecting individual level collusion in online social network, okay? So data collection was a major bottleneck. The reason is that it is impossible to scrape online black markets data, right? Because they have their own strategy to stop our scraper, okay, our crawler. So what we did, we designed something called active probing strategy, where we created some dummy accounts, some empty accounts. We call them honeypots. Honeypots is a well-known term in security domain. So we created honeypots, and then we injected these honeypots to different black market services, okay? And then as if these honeypots are joining black market services in order to gain followers, okay? And then whatever followers we gain, these honeypots gain, we consider them as black market activities, because we did not promote these accounts on social media, or we did not respond to any normal activities. So whatever followers, whatever retweets we got through these honeypots were all safely considered as black market activities. Similarly, you have a set of genuine users who are essentially, we consider that, okay, researchers, scientific researchers, they are generally not a part of black market services. We can safely consider that their accounts are genuine users account, okay? So this is the entire scraping pipeline. I'm not going to details of this, but as you see that we were able, so this is our 3 years of effort to collect black market data. So we got around 36,000 collusive retweets and 23,000 collusive followers for Twitter, okay? So the interesting part is that around 114 such followers that we collected, they are verified Twitter users. So you know what is verified Twitter account, right? Twitter themselves verify whether these accounts are safe or not, right? So there are 114 such users who are verified but still part of the black market services. So it possibly indicates that Twitter is also not very efficient at this moment to spot these collusive activities on their platform, right? So similar statistics we found for YouTube, okay? So some of the notable, so we then started analyzing these the properties of these collusive users. Two notable properties of these users include that premium members. You remember we talked about premium and freemium services. So premium black market members, they are mostly active almost every hours within a day, because possibly that's their day-to-day job, that's their bread and butter. Whereas freemium members are active during the non-office hours. So and that's very intuitive, because freemium members are users like us, right, who oftentimes exploit these activities to do all these fun stuff like promoting things and doing some suspicious activities and so on. So that's not their bread and butter as such. Okay, so the second interesting property is that premium members tend to delete more retweets than freemium members. So there is there is another case of deletion. So you retweet, and then when you see that, okay, you have retweeted a lot of tweets, your account may be suspended, right? So then you delete certain retweets, and then you start acting as a normal user, right? So premium members, the tendency is higher compared to freemium members. The reason is again obvious. Premium members are they are solely part of the black market services, and they do not their account they do not want their account to be suspended. Okay, whereas premium members, as we mentioned, right, they are like free birds. They just join black market services for certain activities and then leave black market services when their jobs are done. Okay, so the first thing that we do when we get some data set is to classify, right? So here the task is to classify premium members versus freemium members. Here the task is to classify collusive members versus genuine members. Okay, collusive users versus genuine users. So first thing first, so we basically ran all different types of classifiers, including decision tree, k nearest neighbors, logistic regression, ensemble methods, bagging, boosting, stacking, random forest, etc. We also tried with perceptron, multi-layer perceptron, etc. And as you see, with this statistical methods, we could get an accuracy of around 70% of F1 score, right? We also compared our methods with 4 other baselines. These 4 baselines, as you see, botometer, spam bot, fake account, ND-sync, these methods were designed for detecting bots and for detecting fake accounts. So you see the accuracy is very low, right? So it basically indicates that bot detection or fake account detection are not same as collusive account detection. Therefore, these methods are not that successful. So even 3-layer perceptron, a simple neural network, is not sufficient. The reason may be that we have less amount of data set. Okay, and another reason could be that bot and fake accounts, as I mentioned, the performance of these baselines methods were not that high, because possibly bot detection or fake account detection is not same as collusive account detection. Okay, so then we designed another method called multitask learning. Okay, this is a very popular method in neural network in neural network setting, where in one for one task, for primary task. Okay, as you see, multitask learning, right? There are 2 different or multiple tasks, right? One is the primary task and others are the auxiliary task. And for primary task, you have less amount of data set, whereas for the auxiliary task, you have plenty of data sets, right? So what you do in that case, you leverage the output of the auxiliary task to improve the output of the primary task. Okay, so here our primary task was to classify collusive versus genuine, right? Whereas the auxiliary task was to predict the number of followers of a user. A number of followers, as you see, as you understand, we have plenty of data sets, because we scraped Twitter and we got a lot of such data set. So this multi-layered multitask learning is designed using this cross-stitch kind of setting, whereas this cross-stitch stuff, the middle layer, which basically is used to share the parameters across 2 different tasks, right? So you see, with the multitask learning, okay, MTL, the accuracy improves from 0.69 to 0.72. Okay, but still it's not that high. So okay, so then we realized that maybe it is happening because one reason is that we may not have enough data, and our data set is pretty much imbalanced, because for collusive users we have very less amount of data. For genuine users we have a lot of data set. We can make it balanced, but that would not serve the purpose, because the real world setting, the real world result, the real world data set is basically a balanced an imbalanced data, right? So then we thought that possibly unsupervised learning is a way to go. because collecting data, label data, is very difficult for certain cases. So therefore, we designed a method, an unsupervised method. We call it core rank, okay, to detect collusive retweeters, okay, of I mean in Twitter platform, okay. So again, since we have already discussed what is this collusive retweeter, so collusive retweeters are those so those users which who are exhibiting both inorganic and organic activities, okay. Sometimes they retweet different black market services accounts, and sometimes they retweet organically, right, as a normal account. So they again they exhibit a mix of both bot like behavior and genuine behavior, okay. So in order to design this unsupervised method for collusive retweeter detection, okay, we proposed two metrics. One is called the credibility of a user, and other is called the merit of a tweet, okay. So what is credibility of a user? Credibility of a user is defined by the meritorious tweets that user has retweeted, whereas the merit of a tweet is determined by the number of credible users who have retweeted that tweet. So you see that credibility and merit, they are dependent upon each other, okay. So so automatically, you can think of some sort of recursive updates of these two metrics, right? So we designed an unsupervised method called core rank, okay, which which recursively computes the credibility of a user and the merit of a tweet by incorporating these four factors, okay. One is the network property. So we constructed a follower following network, right? I'm sorry, a follower following as well as a retweet network. And then we have different behavioral properties of users, right? And we also look at how similar, how topically two tweets are similar. And then we also took into account something called core start problem, which is very popular in information retrieval, which takes care of new cases, new users, or new tweets which do not have enough history, okay. Because if you do not have enough history, you won't be able to create this network structure. So I'm not going into the mathematical part of this. This is already a published work, so you can look at the paper. But a very quick overview of this metric. This is MT is the merit of a tweet, which is determined by CU, which is the credibility of a user, right? Whereas credibility of a user is determined by the merit of a tweet, right? So, and there are other factors, as I mentioned in the previous slide. So here what is happening is that we start with a random numbers, random initialization of MT and CU, and then we recursively update the values of MT and CU, right, with certain properties, of course. So as long as the algorithm converges, okay. So again, not going into the details of this pseudocode, but as you see, we initialize it, and then we update the values of MT and CU, and we stop once we see that that error is below a certain threshold, okay. So the beauty of this method is that it has a theoretical guarantee that it will converge within a certain time, so within a certain iteration. Then and another beauty is that the time complexity of this algorithm is linear to the number of edges, number of links present in the network, okay. And linear complexity helps you make the algorithm faster, right? So theoretical guarantee, high accuracy, as you see here with the increase of where you see the precision for our method is black lines, and recalls also increases compared to the higher compared to the other baselines. And then since there are two factors associated, one is the credibility and the merit, along with the credible users, right, the credible retweeters, we can also detect the suspicious tweets based on the merit score. For those tweets whose merit score is low, right, automatically those tweets are suspicious tweets. So you can detect tweets as well, right? And as I mentioned, this is scalable because this is linear on the number of edges present in the network. Okay, so we developed a browser extension. You can go and try, right? This browser extension, what it does is that you just give the link of a tweet, right? The extension will automatically scrape the retweets of the retweeters of the tweet, and it flags some of them as collusive, and some of them as genuine, right? So you can possibly play with this browser extension. So I have 10 minutes left. So what I do is that I will briefly discuss about the second part of this work, where here we focused on collusive followers. So the first part, so the part that we discussed, there we focused on collusive retweeters. Here we focus on collusive followers. Okay, so the same definition, collusive followers are those who inorganically follow other users, and they are part of the black market services. Okay, so the problem here again is that we do not have enough data, so the deep learning approaches may not be useful in this case. So we have to rely on statistical learning or statistical methods that we have taught in the pre deep learning time period, pre deep learning era. So we know what is follower, what is followee, right? Just as an example, so here A is following E and F, so, and A is followed by B, C, and D. So B, C, and D are followers of A, and E and F, they are followees or friends of A. Okay, so here when we designed this method, we had a hypothesis in mind that collusive followers are very different from fake followers, right? So there have been a bunch of work by Christos Falustos and group at CMU, and they designed different methods to detect fake followers on Twitter by the intuition that fake followers are synchronous in nature. What do we mean by synchronicity here? Fake followers, they follow same set of users, they follow users at the same time, right? So there is a synchronicity in terms of times and in terms of users. Okay, so here we hypothesize that collusive users are not synchronous, right? Since we have defined, you possibly understand that why they are not synchronous, because there is no connection between two collusive users. So collusive users, anytime independently they become part of black market services and they follow others. So the theory of synchronicity may not be applicable for collusive user detection. Okay, so and we'll see later in the experimental results section that fake follower detection methods proposed by Christos and group, they are not useful for collusive follower detection. Okay, so this entire method is based on 4 or 5 observations. So and each of these observations is associated with and part of the objective function that we maximize or that we optimize. So I will, again, for the interest of time, I will quickly go through the observations that we have. So the first observation is that collusive users tend to maintain a well balance between follower and friend counts, thus making them indistinguishable from genuine users. We have already discussed that if you look at the follower versus followee count for genuine users and for the collusive users, as you see here, this red bars correspond to genuine users and yellow bars correspond to collusive users. They look like the distribution looks pretty same for both red and yellow, right? So only based on the follower-followee count, you won't be able to differentiate between collusive and genuine users. Okay, so first observation. So we proposed a method called, this is again unsupervised method. So we generally try to propose unsupervised method. The reason is that data collection from black market services is extremely difficult. So we call this method spot shoe. a matrix factorization based unsupervised learning method for spotting collusive users. Okay, so so what Spotsu does? Spotsu takes care of three factors. One is the user following behavior, tweeting and retweeting behavior, right? Remember, our task is to detect collusive followers, right? In order to detect collusive followers, we're also looking at tweeting, retweeting behavior, and then the linguistic signals that their tweets exhibit. Okay, it is unsupervised. It needs very less temporal information, and it doesn't require any label data as such, right? And what is our aim? Our aim is that we ultimately try to map all the users to an embedding space, to a latent embedding space, which looks like this, a latent embedding space in such a way that collusive users are clubbed together, right? And genuine users are spread throughout this space. As you see, black dots, they are clubbed together, they form a cluster, single cluster, whereas red dots are spread all across the space. Okay, of course, there are certain red dots which are clubbed, and these are basically the errors of our. This is the shortcomings of the method. This is unsupervised, so this kind of error we can possibly tolerate. But nevertheless, in general, this is the aim. We map all the users to an embedding space where collusive users are close together, and genuine users are far apart from each other. So there are four hypotheses. Based on this hypothesis, we designed this matrix factorization framework. So the first hypothesis is that the second one is that collusive users tend to be more aggressive than a genuine user. Okay, because collusive users have certain intensive, they have certain certain incentive to gain credits, right? Therefore, they are very aggressive in following other customers, whereas genuine users, they do not have any incentive as such, so therefore they do not care about following others. So the third hypothesis is that collusive users, there is the only reason for the collusive users to follow other customers is to gain credit. Therefore, it is less likely that the collusive users retweet posts of customers that they follow. Okay, it's again very intuitive that when I join a black market services for following others, okay, as a part of the black market services, I do not care about retweeting my followees post, right? So it is very unlikely that I will also retweet. I may follow, but I will not retweet. Again, based on this hypothesis, we designed a component of the objective function. The last hypothesis was the topical similarity between tweets posted by a collusive user and a genuine user, and their friends tend to be the topical similarity between tweets posted by collusive users and their friends, okay, their followers, tend to be lower than the genuine user. Again, it is very expected because when we retweet a certain tweet organically and we follow another user, and if you look at the tweet posted by my followee and my account, you see that the similarity is very less in case of collusive users, because again, the way we follow is very different from the way we retweet in case of collusive users. In genuine users, you see a lot of similarity because generally we retweet those users who we also follow. Okay, based on that, we also design another part of the objective function, and this is the equation, the final equation. I'm not going into the details of this, but you see that this is the matrix, the main part of this objective function, and these are the constraints. These constraints are coming from three hypotheses that we mentioned. So essentially, we are factorizing a matrix called M. So M is a matrix that we designed at the very beginning. It basically split it into two other matrices. One is U. U is the user latent matrix, and W is the topic latent matrix, right? So we only need U. We do not need W in this case. So comparative evaluation, as you see, that Spotsu outperforms 4 other baselines, which are mostly designed for bot detection or fake detection, fake follower detection, and the gain is significantly higher than the other baselines. Okay, so I have and and another good part about this POTS2 is that it can detect collusive users as early as possible. In fact, with only 1 days of information, you see that it can detect around 77% of collusive users. You do not need second day information, third day information, and so on. So for early prediction also, you can trust on SPOTSU. Okay. So I have 10-15 minutes left, I guess. Let me quickly go through the other research that we are doing at LCS2. So as I mentioned, the major thrust of this of our lab is to explore different cybersecurity related projects. One is collusion, other is fake news, hate speech, etc. So this is one part where we looked at collusion, fraud activities, fake retweets, fake followers, fake Instagram post, fake videos on Twitter, etc. Right? We are also interested in pure fake news detection projects where we looked at currently we are working on multimodal fake news for COVID related cases, right? But we are also looking at fake news activities happened in US election and other Indian elections as well. So there is a collaborative project led by Wipro. This is a tripartite kind of project which is called as Helios, where we are looking at hate speech in Indian context. This is a joint work with a collaborative work with Wipro, UT Austin, IIIT, and IIT Patna. So we are actively working on this hate speech reduction in Indian context and other context. In NLP, there are 2 projects that we are highly interested in. One is called text summarization, abstractive text summarization mostly, where the task that is that you are given a tweet, you are given given a document, a large document, and your task is to come up with a summary of that document in a rephrased manner, right? You can't copy sentences from the document. It's called abstractive summarization. So we are looking at methods for abstractive summarization, a recent paper on that, for neural abstractive summarization published in IEEE. And then we are also looking at bias and fairness aspects in summarization, mostly in ground truth, data bias and system bias. And we got a paper in EMNLP this year as well. So in pure graph mining perspective, the complex network graph mining perspective, we are looking at mostly adversarial attacks in networks, right? Where you have a graph structure, you want to destabilize a certain part of the graph, or you want to part of a certain part of the network. Then what would be your strategy to optimal strategy to destroy the network as much as possible, right? So mostly from adversarial point of view. So if you want to know more about the black markets driven collusion, etc., so me and one of my PhD students, Hridoy, we wrote a survey paper recently on this. It is already up on archive, so feel free to go through this paper, and you will look at, you would see a lot of techniques, recent techniques developed for this one, and for publicly available data sets for codes, etc. Right, everything is available in the survey paper. If you want to know more about the collusion in scientific world, right? You remember the example that I gave at the beginning, 8 level collusion. You can possibly look at this paper, right, where we talk about different types of anomalous citation patterns in scientific literature. Okay, so that brings us to the end of the presentation. A quick small announcements. So we are currently seeking applications for winter internship. So if you want to work on problems related to social computing, NLP, applied machine learning, this link is already up. So feel free to apply. Deadline is approaching November 30. We are also looking for postdocs and senior researchers. There is a joint opportunity, collaborative opportunity at IIIT with Queen's University Belfast. So feel free to also apply there if you fulfill the criteria and and of course several PhD RS positions are available in the group. So I recently, with three of my colleagues, wrote a book on data science for fake news. So this mostly gives you the perspective of different perspectives of fake news surveys, right? And to again tools and techniques, publicly available data set, everything, a comprehensive, holistic view of fake news detection in general, right? In different platforms, it's already available in Springer's site. So also you can feel free to look at it. So that's pretty much it about the presentation. At the end of the presentation, I would like to, of course, thank all the sponsors who have been really generous to support our lab, including Google, TCS, IBM, Egregore, Wipro, Accenture, etc., and of course government agencies including DST and SARV, etc. So thanks a lot.
Thank you so much, sir. It was a very informative session. And in fact, I personally agree with a lot of things which you said, especially the part where you said that publicity is a big challenge nowadays. I have personally encountered these problems, and even sitting in SPS or otherwise, also publicity has been a major challenge for especially people who are not spending on this. They're just relying on
Activity.
organic activities. So, anybody else who has any questions, they can just post it on the chat window. We are open to questions now. Answer is here with us in a while. And so far, I cannot see any questions. I do have a question until we get some. Let me ask you this one. That recently, if you have heard of this news, that there are many studies and many news articles also publishing about how Twitter is either right winger or left winger. There are tweets that are being majorly deleted when it comes to left wing, and they're not doing it with the right wing or the other way around. So the recent case being, I think it's True Ideology or something, if you have heard of.
Yeah.
Some IPS officer was involved in that. So,
Yeah.
what do you have a standard in this, and are you some kind of working on this also?
Well, this is called stance detection in some cases, or polarity detection of news articles. So we mostly looked at this polarity of different news articles, different news editors, not from Twitter's point of view, from editor's point of view, right? For example, you are an editor of a news article, right? So you have certain views about certain things, right? So can you automatically understand, and but you, when you write the editorial report, you write in such a way that it looks like a normal kind of a a middle ground, right? So but the hidden structure, the latent information that's there, can give you some ideas about about your inclination towards left or right, right? So we did some work on that, but that's from news articles point of view, not from a social media's point of view, for example, not from Twitter's point of view, also Facebook's point of view. So this is, there are multiple factors. I mean, the underlying dynamics is very complex. So you do not know what is happening, who is responsible. For example, this Cambridge Analytica case, right? You possibly know in 2016 US election, after the US election, it was revealed that there was this collusion, and then this Cambridge Analytica, they came to the picture, and they actually helped a lot to boost Trump's camp, right? So those are all post facto. So those things will be revealed later, after the actual election happens. So yeah, we are currently working on that. We have collected a lot of data from US election, and we are you actually raising questions like this, the one that you mentioned, that whether certain group of people or a subset of the society were inclined towards left or what, I mean, and Democrat or Republic, whatever, right? And how that impacted the overall discussions on social media.
All right. Thank you for the answer. So I still don't see any comments or questions from the chat window. So I think it's a good time to wrap up.
Yeah. So
And
just to mention this thing to the audience, if you have any query regarding the work or the presentation itself, feel free to reach out to me. My email ID tanmoy@iitd.ac.in, or you can look at this website. Okay, everything is available there. The data, the code, the paper, right, and our day-to-day lab activities, everything. So feel free to reach out to me or any members of the group for further information. Thank you.
thank you, sir, so much once again. And so it's a wrap. Thank you so much.
Thanks. Thanks. Bye. Have a nice day.
Bye bye. Same to you.